Welcome to today's lesson. In this first tutorial, we will solve one-step and two-step linear inequalities. We are in our new unit and we are solving linear inequalities. An inequality, as opposed to the equations that we have been solving, an inequality is an open sentence that contains one of these five symbols. Let's explore these symbols. This first symbol means is less than. Since our number line goes left and right, when we're graphing things that are less than, we would be shading and graphing to the left. We are just less than though, so we don't get to include this first point. We'll use an open circle to say that we're not including it. As opposed to this symbol, which means is less than or equal to. Because we're less than, we're still graphing to the left. We're still shading our number line to the left, but this time because we are equal to, we get to include that first point. So remember, the symbol has a little equal to part right underneath here. It means that we are equal to as well, and we get to fill in this circle with a nice closed dot. Let's look at our next symbol. This symbol means is greater than. When we're graphing things that are greater than, we would be going to the right, so we will shade to the right. Because it's just greater than, though, it's still going to be an open circle. We don't get to include that point. This symbol means is greater than or equal to. So because we're greater than, we're still shading to the right, but because of the equal to part, we get to include this first point. So we'll fill in that hole. So remember, the symbol has an equal to part right here. It means is equal to, and we get to fill in that dot with a closed circle. Let's look at our last one. This symbol means is not equal to. If we are not equal to, then we can be something that's less than. We could be something that's greater than. We are just not something that's equal to. So I guess we would have an open circle right here because we're not equal to it, and shade everything that's less than that number and everything that's greater than that number. Those are our 5 inequality symbols. Let's look at these examples. Let's select the values of x that satisfy the inequality. Somebody has already solved an inequality and they have that x is less than 8. Since 8 is my important number, I like to put that right here in the middle. Because it's just less than 8, I'm going to put an open circle on here because we don't get to include 8. Now we want to shade the numbers that are less than 8. Numbers that are less than 8 would go to the left. So I'm going to shade all these numbers to the left. So let's see which numbers we're talking about. Is 2 less than 8? Sure it is. It's down here. Is 10 less than 8? No way. 10 is over here. So that is not less than 8. Is negative 3 less than 8? Sure. That's way past 0 over here. So that's a good one. Is 8 less than 8? Well, 8 is equal to 8. And since we have an open circle here, we are not including the 8. So we only have 2 answers for this one. Let's look at number 2. This says x is greater than or equal to negative 5. Negative 5 is the important number. I'll put that right in the middle. The equal to part means that I get to include it. So I'm going to put a nice closed circle. And I know that I'm graphing to the right because I'm talking about numbers that are greater than negative 5. So I'm going to shade this. And those are all the numbers that I'm talking about. So is negative 4 one of those numbers? Sure, negative 4 is right here. So that's a good one. Is 0 a good one? Sure, if this is negative 4, then negative 3, negative 2, negative 1, 0 is going to be somewhere right here. And that's fine. Is negative 5 greater than negative 5? No. But is it equal to? Yes. Since that equal to means that we can be equal to, negative 5 works. How about negative 10? Negative 10 is somewhere down here, and that is not acceptable. So these 3 are the correct answers for this one. Okay, now that we know how to shade our answers and what those numbers mean, let's solve 3 more. Let's look at our first one. We're solving and graphing our solutions. Ooh, one important reminder. When we are multiplying or dividing both sides of an inequality by a negative number, we must change the direction of our inequality. Again, when we are multiplying or dividing both sides of an inequality by a negative number, we must change the direction of our inequality. We will flip it from a less than to a greater than, or from a greater than to a less than. Let's see when that happens in our problems. So we've got x minus 8 is greater than 10. Just like we would solve an equation, we can do the same steps for an inequality. It's just that we don't have an equal to sign. Okay, so if I need to get rid of this minus 8, I'm just going to put a plus 8 right underneath it. I'm going to do it on both sides, of course. I draw my line and that goes away. Negative 8 plus 8 becomes 0. X is all by itself. Now adding does not change my greater than symbol. 10 plus 8, of course, is 18. And I have my answers. X is greater than 18. Let's graph those. 18 is my important number, so I will put it right here in the middle. I do not have the equal to part, so I'm going to use an open circle. And I need to know if I'm shading to the right or to the left. Well, greater than means I'm shading to the right. So all of my answers will go this way, and that's it. I've graphed my answers. Let's look at number 4. I need to solve for this x, so I need to get rid of this 3, and I need to get rid of this negative 6. The first thing to go are the things that we add or subtract, so since this is subtraction of 6, I'm going to add 6. I'm going to do it to both sides of my inequality. I like to cross out what I've done right there. Negative 15 plus 6 becomes negative 9. Adding does not change my symbol. I have 3x still. Now I need to get rid of this 3. So that should just be one more step. It's multiplied to my x, so I'm going to divide it away. When I divide by 3, whoosh, that goes away. Dividing by a positive will not change my inequality. Negative 9 divided by 3 is negative 3, and this, of course, becomes x. Now, when I'm solving my inequalities, I definitely want my variable to be on the left side. So I'm going to flip this inequality around. The x is going to come over here, the negative 3 is going to come over here, but this symbol, when I flip the thing upside down, will change. This greater than is eating the negative 3, so this still has to be eating the negative 3 over here, and now it actually is a less than or equal to symbol. So I want my variables to be on the left side. So when I flip the sides, of course that inequality must flip as well. Negative 3 is my important number, so I'm going to put it right here in the middle. I have the equal to part, so I get to include it with a closed circle. And now let's see which way we're graphing. It is less than negative 3, so I'm going to graph to the left. And that's it. We've done 2 of them. Let's do one more. Number 5, I see parentheses, and I need to undo the parentheses first. So I'm going to distribute the negative 5. I'm going to distribute it to the x, and I'm going to distribute it to the 2. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. I have not done anything with my inequality or this other side of it, so that just stays the same. Now I've got my regular 2 steps. I'm going to get rid of the negative 10 by adding it to both sides. Draw my line. I like to cross this out. The negative 5x will be all by itself. Adding does not change my inequality. Negative 22 plus 10 is negative 12. And I have one more step to do. Divide by negative 5. I'm going to divide by negative 5, both sides. This, of course, will cancel away, but now watch out. It says when we multiply or divide both sides by a negative number, we must change the direction of the inequality. I just divided by a negative number, so this must flip around and become a greater than symbol. When we multiply or divide by a negative, we must flip this symbol. So this will be x. Negative 12 divided by negative 5 becomes a positive, and I might just do the decimal, 2.4. That's fine. But remember that we just used this dividing by a negative right here in this problem, so don't forget to flip our symbol. Great. So we have our solutions here. I'm going to put the 2.4 in the middle. That's my important number. I do not get to include it this time, so just a nice open circle. And I'm graphing everything, shading everything that's greater than, so that's to the right. Thanks for watching this tutorial. We will practice this in class and we will do some more in our next tutorial. Bye-bye.